Let's get started. For the first exercise, which you can just follow what I'm doing here, I have prepared a file which I'm now going to open. So if you see my MATLAB window on the screen, there's also some code in it. It's already prepared. And this is some code which you might have produced in this or in a very similar format if you had done the spirograph exercise in the introduction to MATLAB. And we noticed that we have received a large number of spirograph submissions already. So we'll try to set them up for a competition for who did the best spirograph. But let's look at this just in the sense that this is what you were supposed to do and what you probably did according to the instructions. So if I go and execute this code, then what it does, it sets up the arrays as they've been defined here, and it goes through a sequence of plottings. And the result of the plot is now visible in the plot window. And this is, of course, one of the nice spirograph graphs. So in this graphical window, MATLAB has, if you can see where my mouse cursor is hovering in this moment, something that's called rotate 3D. If I activate this, it turns out I can actually move this plot and give a pseudo 3D impression. This is not very interesting in this case because the plot is only two-dimensional, so it's all but flat in the third dimension. But it means that MATLAB is also able to draw 3D graphs, and I'll use this introduction to briefly show you how you can do this based on the piece of code in that script that we have open now. So the first line of this code sets up a couple of points. That could be the axis of points for which we will then elaborate the corresponding values of sines and cosines as we move along them. Then a plot window is opened, and we have something that you should be familiar by now, and if not, make sure you check it before you go forward. A for loop. Here's a for loop set up to go through all the points that we set up in our previous array. Take the points, calculate first something called the x value. It's a combination of cosine minus sine. And next you go and calculate something that is the y value, which is a function combination of sine minus cosine values. And then you plot all this. So what do we need if we want to have a three-dimensional plot? Of course, we need information about the third dimension as well. So one way of doing it, or I'll just do it in this way, I copy one of the lines here, the line that defines our variable y. And if I copy it, I don't want to calculate y twice, but I want to calculate the third dimension, and I assign it the value of z. So I call this variable z. And let me just make some change such that z is not identical to y. So I change the number that defines the frequency here in this argument of the cosine. Take it away such that you can see it well. And we have now a third dimension at least defined. What we haven't done is we haven't really started to plot it. So if we want to plot it, this is how we would go about. You know, plot, P-L-O-T, is the way to plot a graph. And that was the two-dimensional graph that we had before. If you want to do a three-dimensional graph, what you use is a function called plot3. Plot3 is a function that takes 3 arguments and plots them versus each other. So we have to also tell it the third argument, and the third argument in our case will be called z. We have to separate it by comma, and if we do this, we are complete. Then we can run our graph, our script file again, and let's see what the graphical output will be. Well, in the first place, it looks very similar to the previous one. It's actually identical. I go back to my 3D rotate functionality, And if I now move the plot a little bit, you can see that actually we have created something that is very much in the shape of a donut. Nice rotation. Best is if you have it set up yourself, you can then by clicking on it and pulling it with the mouse cursor, rotate it in 3 dimensions and get a nice view and create a more spectacular spirograph.